Good day and welcome to this video in which we are going to look at the value dictionary and the role that it plays in JFunctions. So the concept of the value dictionary is really important for you to be able to construct your domain model using the JFunction concept. So in this video we are going to first of all look at what is a key value dictionary. So in computer programming we normally refer to a dictionary as a key value pair set or a key value dictionary, but I'm just going to use the word value dictionary because that's the way that it's mostly used in the Juno Cassandra documentation. So we'll look specifically at how Juno Cassandra creates the value dictionary at runtime. And then we'll look at the key value pairs related to the raw data and the model parameters. Now here I've introduced two concepts for you, raw data and model parameters. Now there's a previous video dealing specifically at these two elements of the model, these two data elements of the model, and I'll put a link to that video in the description below. So if you haven't yet watched that video, maybe go and have a look at it first and then come back to this video. Then we'll also look at additional keys that are added for you to use in your JFunctions. So in the previous video we explained the concept of the raw input set that you make available to your model, and that during the model initialization stage data is extracted out of that raw input set for each of your model parameters, and as the model then cycles over the different modeling periods, more and more model parameters are added. Another way to look at this is to look at your raw input set like that and your model parameter data as forming a three-dimensional array which is populated as the model runs over the different modeling periods. So now that you just have a refresher on those two data elements of the model, let's look at how the model actually constructs the value dictionary that your JFunctions use during a model run. So first of all, I'm going to look at the initialization stage, and I'm going to imagine that I've got this model with these elements, and I'm going to look at the model is now cycling over each network element, and as it gets to element 10, how does it construct the value dictionary? That is what we want to look at now. So for element 10, what it basically will do is to extract. It's almost like it transposes the keys, which are the column names. So you can see these column names are mapped in a transposed format here, and the values similarly are mapped to a transposed format there. And then in addition to those values, Juno Cassandra will also add additional information into this key value dictionary that you may need to make decisions in your domain model. So for example, it will add for you things like the element index, the current modeling period, the calendar period, which it just uses the model initialization year, and it adds the period to it to convert it to a calendar period. It will give you the name of the next treatment in line for this element if there is something, otherwise it will put none. The name of the next treatment's category if there is something, otherwise it will put none, and the next treatment period and the number of periods to the next treatment. Obviously if there's no treatment, it will just put a very large number here, and that way you can scan forward in your model and see, is there a treatment that is happening soon that I need to take into account. Then also specifically for the reset stage of the modeling, it needs to know whether there is a treatment in the current year. If there is a treatment, that name will be put in there by Juno Cassandra next to the key this underscore treatment name, and also the category this underscore treatment cat, and it will put the values for the current treatment, if any, in there. If there's no treatment, it will just put none and none in there. So basically this is a key value dictionary that your JFunctions can now use to make decisions and calculate new values and so forth. So this consists of, first of all, the raw values extracted from the values extracted from the raw input data, and then additional information about the current cycle in the model provided for you automatically by the framework model. Now, because we are dealing here with the initialization, there's nothing here dealing with model parameters. But at the end of the initialization stage, probably your JFunctions will contain all the logic to add the necessary keys in here that will be your model parameters. So let's look at the next stage of the model, where the model needs to make decisions after it's already got some model parameters. So here I'm in period 1. I've already initialized my model. I still have my raw input set, and I now have my model parameter set at epoch 0. So these are the starting model parameter values. And for both of these sets, I am interested in element index 10, right? And if I extract those values and transpose them, that will give me this key value dictionary. So this is essentially the same as the previous one. However, now I've got this block here dealing with model parameters. So this is the key value dictionary that your JFunctions will have available when it starts to make its calculations during period 1. And it will use the JFunctions that you assign for either initialization or for reset, depending on whether there is a treatment or not. And you don't have to make that decision. JCass will pick your JFunction blocks to use, knowing already that it is going to be either an increment or a reset situation that needs to be modeled. So again, just in the key value dictionary, we've got our raw input data, our model parameter data, and the additional information provided by the framework model. So this is the value dictionary that is made available to your JFunctions. Let's have a look at how an example of how a JFunction makes use of this key value dictionary. So the key element to note is that new key value pairs are added when your JFunctions execute. So let's take an example of a very simple JFunction, which is an equality, and we assume that in your model setup file you've defined this JFunction and you've given it a key f underscore is concrete. So with JFunctions, we require that they always be prefixed with f underscore, and you can add whatever you want as long as it's one word without special characters. So for this example, we assume we've got an equality JFunction and its key is f underscore is underscore concrete. So that means, is this a concrete material or not? And this is the way, the syntax that we used in this example to define our JFunction equality. So let's see what exactly this JFunction instructs Juno Cassandra to do. So first of all, the T colon means that this comparison is going to be done using text. If you had put an N there, it would have assumed this was a numerical comparison. Secondly, the term mat underscore type tells JCass if there is a key in the value dictionary matching mat type, then extract and use its value. Otherwise, use this code mat type literally. So we'll look in more detail at that, what that means just now. Similarly, on the right side of the equation, the term concrete says if there is a key in the value dictionary matching concrete, then extract and use its value. Otherwise, use the value that should be concrete there, not mat type. Use concrete literally. And the colon false at the end just means that the comparison is not case sensitive. So let's look at how JCass at runtime will interpret that equality. So just to restate again, the JFunction for this key has this raw definition. So at runtime, this will translate to AC equals concrete. So how does that work? Well, JCass will go in and it will look, like I said in the previous slide, is there a key matching mat type? And it goes through this list of keys here and it finds, yes, there is a key matching mat type, then extracts its value. And that's what it's done here. And then it goes to this side and says, is there a key matching concrete? And it goes through here and there's no key matching concrete. So in that case, it will use that word literally. So this equality is going to translate to this term over here. and it will make a comparison that's not case sensitive. Now obviously this is not true. The word AC does not equal the word concrete, and therefore this equality will have a value of 0, meaning false, once it's evaluated, and that value will be added against the new key, which is the key of the J function after it has evaluated. So basically, after that J function has evaluated, it is going to add the new key value pair there with its value, which is 0, meaning false. And in that way, when your J functions evaluate from the top to the bottom in a J function block or set, after the execution of each J function, the resulting value will be added to the value dictionary, just like we've shown here. And your additional J functions that execute consequentially will be able to now not only use all of these keys, but it will also have access to this key. So in that way, your J functions will be used sequentially to construct the logic in your deterioration domain model. So that's it for this video. Let's go over the key concepts. Basically, we stated how a key value dictionary is created for each element at runtime. We showed the key value dictionary gives your J functions access to raw data and model parameters for each element as the model loops over the elements. After evaluating each J function, the resulting value, the value that comes out of the J function, is added to the value dictionary using that current J function's key. If your J function reference codes, in other words, the codes that appear in the definition of the J function, if those codes are not found in the value dictionary keys, then JCass will interpret the code literally. So that's a very important concept to consider. So just as a reminder, we are working on the Juno Cassandra documentation, and for the J functions, for example, for the equality that I've explained now, you can find more detailed documentation on the Juno Cassandra documentation website, and I'll put the link for that below. At the moment, it's the 10th of January today. This site, documentation site, is still being constructed, but as far as J functions are concerned, we've got the site where it explains in more detail. For example, if I go to the page dealing with equalities, you can see here the definition of an equality, which is basically what I've just explained to you, and we provide for you information on what type of operators you can use in your equalities and so on. So there's more information dealing with the J functions, but the idea is mainly just in this video for you to understand this concept of the value dictionary and how it relates to the J functions. So that's it for this video. Please watch out for more videos that we will add in this series in the days to come. Thanks for watching.